This Zoom session is being brought to you by the fractal Octaves S. All right, for today, we do more graphs of the other four trig functions. We graphed sine and cosine the other day. Now we're going to graph secant, cosecant, tangent, and cotangent. First, secant, that's 1 over the cosine. So whenever cosine is 0, secant is infinity, and whenever cosine is plus or minus 1, so is secant. And cosine is 0 at n½ pi, so secant at n½ pi is infinity when n is a whole number, and cosine of n pi is plus or minus 1, so is secant at n pi for n integer n. One way I do is you draw the cosine graph like this, and like I say, everywhere where it goes through 0, you put infinities everywhere, and everywhere where cosine is plus or minus 1, so is secant. So it kind of wobbles to plus to minus 1, but through infinity rather than through 0, like that. It's a bunch of u, upside down u, upside down u, upside down u, with of course a period of 2 pi, like cosine. Cosecant is 1 over sine. So, and since sine is a quarter phase out from cosine, cosecant is a quarter cycle out from secant. And sine is 0 at n pi, or integer n, and is plus or minus 1 at n½ pi. And so therefore cosecant of n pi is infinity, cosecant of n½ pi is plus or minus 1. Well, let's see that. So you get a set of u's like this. So let's see. Welcome in. So let's see. Now, tangent is a little more tricky. Well, it's sine over cosine. So sine is 0 at n pi, so tangent n pi is 0. Cosine of 0 is n½ pi, so tangent of n½ pi is infinity for integers n. So, okay, so you graph tangent by putting zeros at the integer multiples of pi and vertical asymptotes in between. And as for the shape of it, well, okay, it's this n shape going from negative infinity through 0 to positive infinity, and negative infinity through 0 to positive infinity, and so on. I like to think of this as spiraling through from 0 to infinity, back to 0 to infinity, back to 0, as if you'd wrap that plane around so that plus infinity meets minus infinity, and you get a kind of spiral. Tangent, just a moment, Mitchell. Welcome in, Mitchell. Tangent, cotangent is cosine over sine. Sine is 0 at n pi, so cotangent of n pi is infinity. Cosine of 0 at n½ pi, so cotangent is 0 at n½ pi for integers n. So you put infinity, you get vertical asymptotes at all the integer multiples of pi and zeros in between. And this one is a constantly falling curve, whereas tangent is a constantly rising curve. And again, I like to think of this as something that spirals around through infinity.
Can you explain how you got those answers?
I'm sorry?
Can you explain how you got those answers again?
Which answers?
It says like equals 0 and equal infinity. How did you get those?
Well, okay. I mean, sine is 0 at n pi, so is tangent. Cosine of 0 at n½ pi, so tangent is infinity there. Because, 0 over something is 0, whereas something over 0 is infinity.
Okay, gotcha.
And again, that works the same for secant and cosecant. Secant is infinity when cosine is 0 at n½ pi. Cosecant is infinity when sine is 0 at n pi. All right. Now, okay. Now, if you do omega, secant omega x, cosine omega x, you shrink the period by a factor of omega. So these have period 2 pi over omega. Same here, tangent and cotangent. You shrink the period by a factor of omega. Since tangent and cotangent have period pi, then tan omega x and cotangent of omega x have period pi over omega. All right, now, so here, graph y equals tan pi over 2x. Okay, first we take the period. You take pi and divide by pi over 2. You get 2, period of 2. So you'd make a table. When x is 0, tan 0 is 0. get a 0. And it's 0 again at 2, and it's 0 again at 4. And it's infinity in between, midway between. So you put zeros at the integer multiples of pi and infinities in between, and a rising curve in between those. Cotangent of a quarter x. Here would be pi divided by this quarter, 4 pi. So you make a table, 0, 4 pi, 8 pi for 2 periods. It's cotangent of 0 is infinity, so it's infinity at 4 pi and 8 pi, and 0 in between those infinities, that's 2 pi and it's 6 pi. So draw these vertical asymptotes at minus 8 pi, minus 4 pi, 0, 4 pi, and 8 pi. Put zeros in between at 2 pi, 6 pi, minus 2 pi, minus 6 pi, and a falling S-shaped curve in between those. Is y equals 2 secant x. Oh, this 2 outside makes it kind of expands the graph, stretches it vertically by 2. Now the period is 2 pi. Here's a 1. I'll make it 1. So the period is 2 pi over 1, 2 pi. So, okay. And at 0, when x is 0, 2 secant 0. Secant of 0 is 1 over cosine 0, which is 2 over 1, which is 2. So it's 2 secant x is 2 when x is 0. And then 1 full period later at 2 pi, it's 2 again. 1 full period later at 4 pi, it's 2. Halfway between at pi, it's -2. And you have a -2 here as well. And between the 2's and the -2's, you have the infinities here, here, here. Pi halves, 3 pi halves, 5 pi halves, and 7 pi halves. So at 0, it's 2. At 2 pi, it's 2. Halfway between pi, it's -2. In between those, it's infinity. So you get a graph like this. And of course, you repeat it going on left and right forever because of the secant is periodic. Secant of 2/3 x, 2 pi thirds x plus 2. Now this plus 2 means you lift the whole graph 2 units, so it moves it up a bit. Period was 2 pi divided by 2/3 pi. That gives you a 3. Now, okay, things get a little complicated. At 0, well, secant 0 is 1 plus 2 makes a 3. At 1 full period later at 3 halves pi. At a half period later at 3 halves. Okay, you have put in x as 3 halves in here, cancel the 2/3, get secant pi. 1 over cosine pi, which is 1 over -1, so -1. -1 plus 2 makes a 1. So okay, it goes from 3 to 1 to 3 to 1 and so on, with a period of 3, half period of 3 halves, 3 to 1, 3 to 1, and so on. And between the 0 and 3 halves, halfway between is infinity. And then, okay, halfway between 3 halves and 3 and 9/4 is infinity, and so on. So at 0, it's 3. At 3, it's 3. At 3 halves, it's 1. And it's infinite between those extremes. So you get these U-shaped curves. So it's a secant curve, a graph expanded vertically by 2 and lifted by 1 or by 2. Okay, so there that goes. And these are similar to the problems you'll be seeing signed in the book. Okay.